All right, hey gang, I'm gonna walk you through one of the reviews that I handed to you. My purpose in doing this, I want to make sure you do it before you actually watch the review. And if you just copy down the notes, you're not helping yourself. I mean, you may you may glean some understanding of what I want you to know, but it's kind of like this. I want to make sure that we head off any problematic areas before we get to class. So with that being said, let me go ahead and put this down for you. I'm going to get right into it here. So right now, algebraic expression for each verbal expression, 6 more than a number. I'm going to go ahead and do the number is going to be x in this case, more than is plus. I'm going to say 6. Okay. In this case, this is the same as doing 6 plus x. Okay, I don't care whichever way you want to do that. Number 2, 12 less than the product of 3 and a number. Okay, now this less than, if you think about it, if you have $12 less than me, you have to take my dollar amount and subtract 12. So what you need to do here, if we're taking 3 times a number, 3 and a number, the product is times. Okay, so 3x, 3 times a number, the product of 3 and a number, less than 12. We have this amount, and we're going to take 12 less than that. So I'm going to subtract 12. Okay, that's the tricky one because you have to flip-flop it. Okay, this one plus, you can leave it however way you want. 4 divided by the difference between a number and 7. We have the difference between number and 7. So I'm going to take the difference between a number and 7 is to subtract. And then I'm going to take 4 divided by that. So I'm going to go ahead and do this. 4 divided by the difference between a number and 7. Okay. You can also do this. 4 divided by x minus 7. Okay. Either way would give you the same exact answer. Okay. Now, I'm going to encourage you, as we move into this next section, to go ahead and fill out PEMDAS, because you need to be able to think through what comes when. So when I look at this, the first thing I know is I'm going to do is I'm going to square this. Okay? The next thing I'm going to do is I'm going to divide. So 8 divided by 4, 32 divided by 4 is 8. And then I'm going to add, subtract left to right. So I'm going to add 4, which is 12, minus 3, that's 9. There's my answer. Okay? All right, so again, using PEMDAS there. All right? All right, so moving on to number 5, we have PEMDAS says parentheses first, so 4 times 2 is 8. Gonna leave that in parentheses. And then we have exponents. So I'm gonna do 8 squared, which is 64. And I'm going to do 3 squared, which is 9. Okay. From there, I'm going to add so that I can eventually divide, because this is grouped together underneath of the fraction. So I'm going to do 64 divided by 16. And in the end, my answer to number 5 is going to be 4. Okay. All right. For number 6, I'm going to plug in these values for the letters here. So we end up having 6 squared plus 2 times, actually I should put that in parentheses too, plus 2 times 6 times 4 plus b squared, which is 4 squared. Okay. Now, I'm going to do the exponents first. 36. I'm also going to go ahead and multiply these together. 2 times 6 is 12, times 4 is 48. And 4 squared is 16. Okay. Now from there, if I add these together, 36 and 48, let's see, 70 and 14, so 84, plus 6 would be 90, plus 10 would be 100, so C is going to be my answer there for number 6. Okay. The next ones, again, working through these, we have 13 plus, and I'm going to do the 4 squared first. So I don't square the negative here because it's not in parentheses. So I'm going to square the 4. And then I'm going to do the parentheses, which would be 16 minus 16, which is 0. So my answer is lucky number 13 on number 7. The next one, I have 9 divided by, and we work from inside out, so the parentheses here comes before the brackets. 7 minus 5 is 2. Okay. From there, 9 divided by 2. This is interesting. You can put 4.5 in here and multiply that by 2/9, but watch what happens here. If I keep this in the brackets here, 9 divided by 2 looks like this. Okay, and this is multiplication here. So this is actually going to be 18 over 18. So my answer for number 8 is 1. Okay, now if you were to do the 4.5, just showing on my calculator here, 2/9 times 4.5, again, it still gives you 1. Okay. For the last one, just straightforward addition all the way through. So 30 plus 20 is 50, 60, and then 80. I'm just doing this in my mind. So 7 and 9 make 16, plus 4 more is 20. So we should have a total of 100 for number 9. Okay, you can double check my math there, and you can tease me till no end if that is wrong. Okay. For number 10, we're using the distributive property, so I'm going to distribute 4 to both these terms, and I cannot simplify them because they're both unlike, so I leave it just like that. Okay. Here I'm going to distribute a -3, so I get a -15p plus 6, because a negative times a negative is a positive, and I cannot simplify those because they are unlike terms. Number 12, a company operates 3 movie theaters. The chart shows the typical number of tickets sold each week at the 3 locations. Write and evaluate an expression for the total typical number of tickets sold by all 3 locations in 4 weeks. Okay? Write and evaluate an expression for the typical number of tickets sold by all 3 locations per week. Okay? In 4 weeks. So let's see here. Let's see. If I were to go ahead and do this, 438. Let me check something here real quick. Okay, so we're not going to have to do numbers 12 and 13. I want to get rid of those there. Let me look at number 14. A teacher wants to compare the academic work of 2 classes. Which average for each class would you suggest that he use? I'm going to get rid of 14. We haven't really covered some of those things, and so I'm just going to be done with that. To look at number 15, it says express the relation in each table, mapping or graph as a set of ordered pairs. So in number 15, if I want to express this as a set of ordered pairs, the set is going to have this bracket right here. And the ordered pair would be this, -2, 4. It's easy with the table. 1, 2, 3, 0, and 4, -2. Okay? So those would be the ordered pairs there. The next one, now what I would ask you in the next one is this a function or not? And the answer would be no, because -3 goes to both 2 and 4. Okay? But we're just expressing these as a set of ordered pairs, so I'm going to say -3 goes to 2, and -3 goes to 4. -1 goes to 0, 0. And 1 goes to -2, and 3 goes to 0. Okay, so sorry about that, I went off the screen there. But I just grouped those ordered pairs together, and that's all you have to do to state it as a set of ordered pairs. Okay? All right. Now, to finish this off, we have some questions that, these are important, these last couple questions here. So the first one, determine the domain and range. Remember, the domain is all of the x values. So I'm going to say the domain would include 2, -1, 0, 3, and -4. And the range would include the following numbers, the y values, which would be 5, 3, -1. I'm not going to repeat 3. I'm going to put -2. Okay? So again, the domain is all the x values, the range is all the y values, d comes before r, x comes before y. Okay? Determine if this is a function or not. I like to do the mapping version of this. I just think it's the easiest to see. So if I go ahead and do 2, actually I'm going to start out with the smallest number here. Let's start out with -1. And then I'm going to go, actually -2 would be the smallest, wouldn't it? -1, 0, 2, and 3. And then from there, the smallest number we have 2, 3, 4. So we have 2, 3, and 4. I believe that's it. So 2 goes to 3. -1 goes to 3. 0 goes to 4. 3 goes to 2. And -2 goes to 3. So as we look here, each one of these inputs goes to exactly one output. So as a result, is this a function? Yes, it is. Okay. Looking at number 19, we've practiced these. We're going to plug these in. Don't forget to put parentheses around it. Okay. Order of operations, 9. Then we go ahead and multiply 21 would equal 30. And then for this one, f of -6y, I'm going to go ahead and plug this in, -2 times -6y. Ignore that right there, okay? So here I have a double negative, and when I multiply, I get a positive 12y. And I can't combine those two because they're unlike terms, so I leave them just like that, okay? For the last one, identify the function graphed as a linear or nonlinear. Obviously, it's nonlinear because it's got a little curve to it, so nonlinear. Okay. Then estimate and interpret the intercepts of the graph. Okay. Well, time since release, so gadgets sold by thousands. So the only intercept is at the origin, which would mean that they hadn't sold any at the time that they hadn't opened. Okay, once they started opening, it was a gradual growth in sales. Okay, any symmetry? No, there's no symmetry. Where the function is positive, negative, increasing, decreasing. Okay, so this is all positive here. This whole function is all positive. It's above the x-axis. Increasing, we're going from left to right. It looks like we're in an upward motion here. Okay, we're still in an upward motion. We're starting to plateau. If we start a downturn, that's when it's going to become decreasing. The x-coordinate of any relative extrema. Well, I can't say that this is a relative extrema because I don't know what it's around. If it starts to curve downward, this would be a relative extrema. Okay, this would be a relative maximum. Okay. And the end behavior of the graph, we didn't even talk about that, so we're not even concerned about it. Okay. All right. So that was kind of just a quick overview of how to work through the review there. I hope that made sense. Bring questions to class and we'll go over it. Okay. Thank you for your time. Have a good day.